Hello, welcome to my channel MathWithNazia. In this channel, you will find a lot of tips and tricks across all the topics in math. If you are new to this channel, click on the subscribe button and hit the bell icon so that you get a regular updates of all my videos. So in today's video, we are going to learn about trigonometry. So this is a very important chapter. So first, let's see what is trigonometry. So trigonometry is nothing but it's a Greek word. It's a Greek originated word. It is divided into two parts, trigno and metry. Trigno means triangle. So we use this in triangles. Metry means measure. So we are going to measure the triangles. So triangle has three sides and three angles. So trigonometry is a study of a relation between the sides and angles of a triangle. So we are going to study the relation between the angles. So it has three angles and three sides. So we are going to study the relationship between these three sides. Now, usually students ask, why do we learn trigonometry and where are we going to use this? Right? So for example, you are standing here in the point A, and there is an Eiffel Tower here. This B and C is an Eiffel Tower, and you want to know the height of an Eiffel Tower. So you can't take a tape or something to measure the Eiffel Tower. So instead, you can know the distance, how far you are from the tower and this angle. So using the distance and the angle, we can find the height of the Eiffel Tower. So trigonometry is used in our day-to-day life to find the distance. We can also find the distance from the ground to the person, or we can find the height of the Eiffel Tower. So trigonometry is used to find the height, distance and the width from a particular place instead of measuring just by using mathematical calculations. So trigonometry has a specific role in our day-to-day life. And as you could see, we apply trigonometrical ratios and all the things would be done only in a right angled triangle. So we use trigonometrical ratios and trigonometrical measure to find for a right angle triangle. Not for any other triangle, it is only for the right angle triangle. So you will understand as we start doing our questions. Now, let's take this triangle ABC, which is a right angled at B. So, B is 90 degree. As I have already told you, in trigonometry, we will apply only for right angles, right? So, now let's start naming the sides. So, this is a right angle. So, the side opposite to the right angle is always the hypotenuse. I think you all know this. We have already learned in Pythagoras theorem. This is the longest side. So the side opposite to the right angle is called as hypotenuse. Now we are going to take any one angle. So now let's take this angle A. So when I'm going to take this angle A, so we are going to do it in reference to angle A. So with reference to angle A, so the side exactly opposite. So this is the angle exactly opposite, which is BC. This side is called as the opposite side, or you can call it as the perpendicular side because it's a standing line, because it's a straight vertical line. So either we call it as a perpendicular or we call it as an opposite. Usually we use perpendicular, but few use opposite. So the side exactly opposite to the reference angle is the opposite side or the perpendicular side. And the side which is directly adjacent. Adjacent means which is nearby. Usually the word adjacent means the nearby side. So with reference to angle A, AB is our base. Now we have named our side. AB is the base, BC is the perpendicular and AC is the hypotenuse. Now in trigonometry we use like sine, cos, tan, cosec, sec and cot. So these are the new terms which you are going to learn. So we have 6 trigonometrical ratios. So let's start writing the 6 trigonometrical ratios with reference to angle A. We can do it with angle C also. That I will teach you the later part. So first let's learn with the reference to angle A. So first is the sine A. What is sine A? Sine A is nothing but perpendicular by hypotenuse. That is P by H. Easy. Sine A is nothing but perpendicular to hypotenuse. Then we have cosine. Either you can write cosine or you can just write cos A. Usually cosine will write it as cos, but when the actual word is cosine, we write it as cos. So cos is nothing but base by hypotenuse. Isn't it easy? Sine is perpendicular line by hypotenuse. Cos is base by hypotenuse. Easy. Now let's see the third one, which is the tan. Tan A. What is tan A? Tan A is nothing but, we will not take a hypotenuse here, we will take perpendicular by hypotenuse. Sorry, perpendicular by base. Pretty easy. You can just remember this. Sine A is nothing but perpendicular by hypotenuse. Cos A is base by hypotenuse. Tan A is perpendicular by base. Easy. Now the other three are just the reverse of this. The reverse of sine is cosec. We have a cosec A. What is cosec A? It's just a reverse of sine A, which is hypotenuse by perpendicular. We just need to flip it around. And what is the opposite of cos? What is the reverse of cos is? Sec A. Sec A is the opposite of cos. So here also we will just reverse it, which will be h by b, that is hypotenuse by base. And the reverse of tan is cot. Cot A is b by p. Isn't it very easy? You just need to remember the first part. Once you remember the first part, you have to just reverse it for the cosec. So you have to remember this. The opposite of sine is cosec. The opposite of cos is sec. This is little different. So usually students confuse the opposite of sine is sec and the opposite of cos is cosec. No, that is not the way. The opposite of sine is cosec and the opposite of cos is sec. So please remember this. So this is with the reference of angle A. Isn't it very easy? Now I have drawn the same triangle again. I have not changed the side. So this is for you to understand, so that you have the reference, both a reference, and you can understand this easily. The same triangle, it is right angled at B. So since this is the right angle, which is our hypotenuse, right, AC is our hypotenuse. So hypotenuse is the same. There is no change in this. Now earlier we took the reference angle as A, right? Now we are going to take the reference angle as C. So here the reference angle is C. So which is our base and which is our perpendicular? The side directly opposite to the reference angle. So the reference angle is C. The side directly opposite to the reference angle is our opposite side or perpendicular. So here AB is our opposite side or perpendicular. And the side adjacent, that is next to it, which is whichever is close to it, that is the base. Easy. Whichever side there, whichever angle, whichever is the reference angle, just opposite to it is a perpendicular, and which is next to it is a base. This hypotenuse will never change. It will remain constant. Only these two flip around. Right? Now let's write the same six trigonometrical ratios with reference to angle C. So I'm writing all this so that you don't get confused in this. This is the basic of trigonometry. You can be very clear in this. So once you are clear in this, you can do the trigonometry very easily. So now the same way sine C. So now I'm going to take sine C. So sine C here, again the same formula, perpendicular by hypotenuse. So which is our perpendicular side here? Our perpendicular side here is AB. It is not BC. It is changing. Here it is AB by AC. So this is a difference. The same formula is same, but the side changes. Here I have not written the side because you understood for the first time. Now to compare, I am writing the sides. So sides is not necessary to write. It is only for your understanding. Same way now, what is cos C? Cos C is the same formula, base by hypotenuse. So here what is our base? BC. So it is BC by AC. Easy. It's the same, only the sides are changing. Now tan. What is tan C? Perpendicular by base. What is our perpendicular here? AB. AB by BC. Easy. And the reverse of this is cosec, sec and cot. I think you will be able to write that easily. So it is just that you remember the first three formulas, and one point to remember is the side exactly opposite to it is opposite side or the perpendicular side. The side which is next to it, that is the base side, that is which is adjacent to it. Pretty easy. Do not forget this concept. Angle, whichever the reference angle we are taking, exactly opposite to that is our perpendicular, which is next to it is our base. Be pretty clear in this. This is very basics of our trigonometry. Now let's do few questions related to these trigonometrical ratios. Now let's see the first question for today. In a triangle, a right angled at A, if AB equals 12 cm, AC equals 5 cm, find all the 6 trigonometric ratio of angle B and C. So we have to find trigonometrical ratios of angle B, all the 6 trigonometrical ratios like sine, cos, tan, cosec, sec and cot. We have to find all the 6 for B as well as C. I am taking this as a vast question because so that you will understand how do we form the ratios for B and separately for C. Right? So this is our picture given, the figure given. Triangle ABC, right angled at A. So whichever angle is right angled, that you will put here. This is the right angle. And what else is given? AB is 12 cm. So this is 12 cm and AC is 5 cm. So now first we have to find with the trigonometrical ratio with B. So when we put B here, when we take this as a reference angle, what have I explained you? Which is the opposite side? Yes, this is the opposite side. This is either called as opposite or perpendicular. We usually write it as a perpendicular side. And this is our base. But what about our hypotenuse? Our hypotenuse side is missing here. So how are we going to find? How are we going to find the hypotenuse side? Any idea by seeing this triangle? Right. We are going to use our Pythagoras theorem. I hope you all remember the Pythagoras theorem. We will use Pythagoras theorem and find the hypotenuse. So first we have to find BC square. So BC square is equal to AC square plus AB square. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So here we have AC square is 5 square plus 12 square. So 5 square plus 12 square is 25 plus 144. 25 plus 144 we get it as 169. So BC equals, since there is a square here, squaring on both sides, this will give 169, root of 169. So what is root of 169? So BC equals 13. So to do this trigonometry, it is better if you remember all the square numbers. What is 5 square, 12 square, 13 square, till 25 square. This will be really helpful so that you are able to find the square root and you are able to do the square. So now we have got the value of BC as 13. So we have got the hypotenuse as 13. Now let us find out all the 6 trigonometrical ratio with reference to angle B. So we are taking the angle B. So we know which is our perpendicular side, our base and our hypotenuse. So since it's reference to angle B, we are going to find out sine B. What is sine B? Perpendicular by hypotenuse. So what is our perpendicular here? 5. So it is 5 by 13. Then we are going to do cos B. What is our cos B? Base by hypotenuse. So what is our base here? 12. 12 by 13. So I'm just going to apply whatever we have got it here. Then we are going to find tan B. What is tan B? Right. Perpendicular by base. So perpendicular by base is 5 by 13. Isn't it easy now? Now we have found out sine, cos and tan. So what are the other 3 trigonometrical ratios? Right, they are cosec, sec and cot. So let us do that here. So the opposite of sine is cosec. So cosec is equal to cosec B is equal to, yes, the reverse of sine. So here we will be having hypotenuse by perpendicular. So which is just the reverse of that. You can directly write it as 13 by 5. Then let's find out sec b. What is sec b or secant b? Whichever is easy for you, you can tell that. Which is hypotenuse by base. I'm just going to write the reverse of this. Hypotenuse by base will be 13 by 12. And the reverse of tan is cot b, which is base by perpendicular. So since it's perpendicular by base, here it is base by perpendicular. So this would become 13 by 5. Clear? Now is it very clear how to write the trigonometrical ratios with reference to angle B? Now we are going to do with reference to angle C, because that is also a question. I've done that. I've written that as an extra question so that you understand the difference between reference of angle angle B and angle C. Now I have drawn another picture. The same picture I've just repeated. Triangle ABC, right angled at A. And I've written the length of each side. Now we have to see the reference angle C. So for the reference angle C, which is the perpendicular, which is the opposite side, the 12 is the opposite side. So this is our perpendicular here. And the alternate side, that is 5. So this is our base. And this is our hypotenuse. So when we have the reference angle C, there is a slight change in base and perpendicular. Here the perpendicular is 5, base is 12. Here the base is 5 and the perpendicular is 12. So since this is with the reference of angle C, and hypotenuse will never change, it will remain the same. So now let's find it out. So same thing with sine C. So we are going to find out sine C. Sine C is equal to perpendicular by hypotenuse. So here our perpendicular is 12. So it is 12 by 13. And now let's find cos C. Cos C, which is base by hypotenuse, which is equal to, what's our base? 5. 5 by 13. And then tan. Tan C. Tan C is perpendicular by base. So perpendicular is 12. 12 by 5. Easy. The same thing we are going to repeat, but with a different base and different perpendicular. Now the same thing we are going to find the converse of it. So for the, what is the converse of sine? The opposite of sine is cosec or cosine. Whichever is easy for you, you can tell. So cosec C is the, just we have to reverse this. So it is hypotenuse by perpendicular. So hypotenuse by perpendicular will be, here we have 12 by 13. So here our answer will be 13 by 12. And sec the secant C, which is base by hypotenuse. So here we have 5 by 13. We can just directly reverse this as 13 by 5. Easy. Now tan C will become cot C. Cot C is, right, cot C is base by perpendicular. Base by perpendicular, we are just going to reverse the cot, which is 5 by 12. Isn't it easy? Now I think you have understood how to find the base and the perpendicular for the angle given, right? So if you found this video interesting and it was useful for you, do not forget to click on the subscribe button and hit the bell icon so that you get a regular updates of all my video. And if you like the video, do not forget to hit on the like button. Now let's see the second question for today. So the question is, in a triangle ABC, right angled at B. So the main point to notice, it is right angled at B. If AC equals 5 centimeter, BC equals 3 centimeter, find sin A, cos C, tan A, cosec C, secant square A minus tan square A. So this is our question. So here A and C reference angle is mixed up together. So you have to be very careful in writing this. Now let's draw the figure for this question. So I have drawn this triangle ABC right angled at B. So the B is 90 degree here. Now what else is given? If AC is 5. So we know the hypotenuse side, which is 5 centimeter. And we know BC is 3 centimeter. Now we have to find out all these 5 questions. So now as you could see, there is one side missing, right? we don't have AB. So first let's find AB. So how are we going to find AB? Any idea? Right, we are going to use our Pythagoras theorem as we did it in our previous question. Now what is a Pythagoras theorem? Hypotenuse square is equal to sum of the squares of the other two sides. Right? Now let's use that. So here we would write AC square is equal to AB square plus BC square. Right? This is our Pythagoras theorem. So we know what is our AC. AC is 5. So 5 square equals, we don't know what is AB. We have to find our AB. This will remain as such. And BC square is 3. So that is 3 square. Now I'm going to bring this 3 this side. So 5 square is 25. Minus 3 square is 9. This comes this side. Whenever plus moves to the other side, it becomes minus. Equals AB square. Now 25 minus 9. What do we get? We get 16. 16 equals AB square. But we have to find AB. Squaring on both sides, this will be equal to square root of 16. So what is square root of 16? AB is 4. Yeah, 16 is a square number. So now we have got the value of AB. So AB is 4. Right? Till this it's clear. Now let's see the first question. We have sine A. So this is a reference to the angle A. So with reference to the angle A, which is our perpendicular side? The opposite side is our perpendicular side. So this is our P and this is our base because this is the adjacent side. So opposite side is the perpendicular, adjacent side which is nearby to it is a base, and as usual this is your hypotenuse. This will not change. So the first question, A question, is sine A. We have to find sine A. What is sine A? We have already learnt. So sine A is perpendicular by hypotenuse. So what is the perpendicular here? It is 3. So 3 by our hypotenuse is 5. So sine A, the answer is 3 by 5. Now when you see, we have cos C. Now we have to find with the reference of angle C. So with reference of angle C, our perpendicular and base will change. So now let's see which is our perpendicular. Let me change the color so that it is easy for you to identify. So now when reference with angle C, with reference to angle C, the opposite side is 4, right? This AB is the opposite side. So this becomes our perpendicular. So for reference angle C, this becomes the perpendicular. For reference angle C, BC becomes the base. I have written in green and that I have written in blue so that it helps us to check the difference between the numbers. Now let's do the question number B. What is our question? Cos C. We have to find cos C. So what is cos C formula? We have base by hypotenuse, right? So what is our base here? See this, you can see whenever we use the alphabet C with reference to the angle C, we will use with the green color. So our base is 3, that is BC. So 3 by 5, hypotenuse is same, so I have not differentiated. Hypotenuse is same for both the angles. Now again we have tan A. So now again we are going to do the reference angle A. So I've changed the color again so that you differentiate between these two reference angle. So now tan A. So what is the formula for tan A? Right, it is perpendicular by base. So what is our purple perpendicular here? This is 3 because that is with the reference of angle A. 3 by our base is 4. So it is 3 by 4. Easy. Now we have to find cosec C. Cosec C now with reference to angle C. So let's do the D question, which is cosec C. Cosec C is the reverse of which thing? Is it reverse of sine or cos? Yes, it is the reverse of sine. So reverse of sine is h by p. You just need to reciprocate it. H by p. So what is our h by p? We will see the green color. Which is our h? H is the common 5. And what is the perpendicular in green? This is 4. So you have to differentiate. If you're not able to differentiate with color, you can draw two diagrams and differentiate it. One angle with reference angle A, another reference angle C. Now Our last question is secant square A minus tan square A. So this is little different. We have not used square so long. Now we are going to use the square. So our E question is secant square A minus tan square A. Now both are for A. What is secant square A or sec square A? Yes, that is the opposite of cos, which is hypotenuse by base. So hypotenuse is 5. 5 by what is our base here, which is in perpendicular base, which is 4. So it is 5 by 4, this square, because secant square, so I'll just put a square, minus tan square. What is the formula for tan? Perpendicular by base. So perpendicular by base, already we have found a tan here. You can directly write it from there. So it is 3 by 4 the whole square. So now when you square this, we get it as 25 by 16 minus 9 by 16. And since these two are like fractions, we can directly subtract it. So 25 minus 9 is 16. So 16 by 16. So the answer is 1. 16 by 16 is a full fraction. So the answer becomes 1. So secant square A minus tan square A is 1. Isn't it easy? I have differentiated with the colors. You can refer that. And if this is confusing, you can draw a separate triangle for reference angle C. This will be little tricky still if you are doing few questions. Once you practice some more questions, it will be very easy for you to work it out. So I hope the basics of trigonometry, the very basic part of a trigonometry is clear for you. If you have any doubts in this particular topic, you can comment down in the comment section. I will try to clarify all your doubts. In this channel, you will find a lot of tips and tricks across all the topics in math. If you are new to this channel, click on the subscribe button and hit the bell icon so that you get a regular updates of all my videos. So in today's video, we are going to learn few tricky questions about trigonometry. I have already explained the basics of trigonometry, where is trigonometry used and how are we going to use in our day-to-day life, and the basic formulas which are used in trigonometry. And we have done few examples regarding that. If you have not watched that video, you can refer that. The link is given below in the description, or you can simply click on the I button given above. So now let's see the first question for today. For the given figure, if cos alpha equals 5 by 13 and cos beta equals 3 by 5, find the length of BD. So our question is, cos alpha equals 5 by 13 and cos beta equals 3 by 5, find the length of BD. So they are asking us the length of BD and the figure is given here. As you can see, there are two triangles in this picture. We have a triangle ABC, which is a right angle triangle. Again, we have CDE. This is also a right angle triangle. And we know what is AB. AB is 12. And the reference angle given here in this triangle is alpha. And when you take this triangle CDE, we know what is ED. ED is 8. And the reference angle is beta. So I hope you all remember what is a reference angle, what is a base, what is a perpendicular, hypotenuse. We have already learnt in our previous video. So let's see what is given to us. First, let's take this first triangle ABC. So in triangle ABC, what do we know? We know that cos alpha equals 5 by 13. So they have given cos alpha as 5 by 13. So what is cos alpha? What is the formula for cos alpha? Right, it is base by hypotenuse. Right, I hope you know what is a base. A base is the side which is corresponding to the reference angle. So our reference angle is alpha. So our base is BC. So the base is BC. And what is the hypotenuse? Hypotenuse is the side exactly opposite to 90 degrees. So here the 90 degrees angle B. The side exactly opposite to the 90 degree, which is AC. So AC is the hypotenuse. Either you can remember like this, or AC is the longest side of the right angle triangle. Both are right. So now we know BC as 5 and AC as 13, but that is not the actual value. So what we would do is we will keep BC equals 5K and AC equals 13K. So first we have to find the exact value because AB is already given, right? So now which theorem can we apply? Right, we can apply the Pythagoras theorem. So what is a Pythagoras theorem? Yes, the sum of the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the square of the hypotenuse, which is AC square, equals the square of the sum of the squares of the other two sides. That is AB square plus BC square. Now as you know, what is AC? 13K. So 13K the whole square equals, what is AB? AB is 12, that is 12 square. What is our BC? 5K the whole square. So now let's solve this. 13K the whole square will be 169K square equals, what is 12 square? 12 square is 144 plus 5K the whole square. 5 square is 25 and then K square. So for this type of a question, it is very important that you learn the square numbers. Try to learn the square numbers from 2 to 25. So 2 square to 25 square, if you remember it clearly, you need not waste time in working out. Now for example, we have 13 here. You need not sit and multiply 13 times 13 and waste your time. Rather you can remember this. This is a very easy numbers. It's only 169. So try, if you are able to memorize from 2 square to 25 square, that will be pretty easy for you to work out these type of questions. Now let's bring all the k's to the one side and the number to the other side. So we are going to bring our variable to one side and the constant to the other side. So it is 169k square minus 25k square equals 144. So 169k square minus 25k square equals 144k square equals 144. So both the sides we have 144. We can write it as k square equals 144 divided by 144, which is equal to 1. Since k square is equal to 1, k is also equal to 1. So now we have the value that k is equal to 1. So therefore we know that BC is equal to 5. 5 times 1 is 5. And AC is equal to 13 because it is 1. It will give us the same answer. So now we have found out what is BC. BC is 5 and AC, which is 13. So we have found out all this. Now, but what is our question? They are asked us to find out BD. So to find out BD, we still need what is CD. So same thing we are going to apply and find out what is CD. So come on, now let's try to find out what is CD. So now let's take the other triangle which we have, that is triangle C, D and E. So in triangle CDE, what do we know? We have the reference angle as beta and we know ED is 8. Cos beta equals 3 by 5. So we have cos beta as 3 by 5. So as we have already learned, this is our base and this is our hypotenuse. So in this question, which is our base? Can you please guess it? Because reference angle is beta. Right. So the base is CD and which is our hypotenuse? Correct. Our hypotenuse is EC because D is the 90 degree. So that is EC. So now we know what is CD and VC. So we can keep as CD equals, since this is 3, I will keep it as 3P. You can take any alphabet, X, Y, Z, anything. I just took it as P. That time I took it as K. Now I have taken it as P. Now we know CD equals 3P. And what about EC? EC equals 5P. So same Pythagoras theorem I am going to apply here. And we know ED is 8. So now let us apply, which is our hypotenuse? EC. So hypotenuse square is equal to the sum of the squares of the other two sides. CD square plus ED square. Anything ED, DE, both are going to be the same. So now what is EC? We have 5P the whole square equals, what is our CD? 3P the whole square plus 8 square. So 5P square is 25P square equals 9P square plus 64. Let me bring it everything to the same side. 25P square minus 9P square equals 64. So 25 minus 9, which is 16P square equals 64. So P square equals 64 by 16. So what do we get? Right. So we get it as P square equals 4. So P equals 2. So now we have found the value of P. So now we know what is P. So now let's find out what is CD and what is EC. So I have to draw lines and complete this in the same thing. So you have a reference of the total question. So now what is our CD? CD equals 3P. So 3 times 2, which is 6. Now we have got our CD as 6. Right? Now we know what is CD. Now what is EC? EC equals, it is 5. 5 times 2 is 10. Now we have our EC as 10. What is our question? Our question is BD. So what is BD? BD equals BC plus CD. So as we know what is CD? CD is 6. This is 10. So these are the values we have found out. But we want only BC and CD. So what is BC? BC is 5 and CD is 6. So the value of BD is 11. So now we have got our answer. Isn't it easy now to find? We just took two different right angles, found out the values of the base and the hypotenuse, and found the final answer. So this is the way you always split the question and find out the answer for that particular question. So I hope this method is easy for you to understand. If you found this video interesting, click on the subscribe button and hit the bell icon so that you get a regular updates of all my video. To this channel, click on the subscribe button and hit the bell icon so that you get a regular updates of all my videos. So today we are going to learn a very tricky question about trigonometry. I have already explained you the basics of trigonometry, how is it used in our day-to-day life in my previous video, and we have solved few questions also in my previous video. If you want to refer that, you can check on the description, the link is given there, or you can just simply click on the I button given above. Now let's see the question for today. In the following figure, AD perpendicular to BC, AC equals 26, CD equals 10, BC equals 42, angle DAC equals X, angle P equals Y. Find the value of cot X, 1 by sine square Y minus 1 by tan square Y. And the third one is 6 by cos X minus 5 cos Y plus 8 tan Y. Usually my students get confused in this type of question. So I thought I can make a video to explain them clearly. So now let's see, there is a triangle given to us ABC, right? And AD is perpendicular to BC. Clear? AD is perpendicular to BC. Now what else is given? AC equals 26. So here AC is 26. This is also given. CD, this small part. CD is 10. This is also given. BC, the whole part, the bigger part, BC is 42. This is also given. So if BC is 42, CD is 10, what is DB? Right, DB is 32. So we also know DB. And what else is given? DAC angle. This is angle X and this is angle Y. So these are our two reference angles. Right? So now let's start finding the sides which is missing. And then it is pretty easy for us to find the values. So now as you could see, we have ABD and ADC, two triangles are here. And since this AD is perpendicular to BC, we all know that this is 90 degree on both the sides. So we have our right angle triangle. So first let's take the triangle ACD. Okay, so now we are going to take the triangle ACD. So triangle ACD. So what do we need to find here is AD. We know what is AC, we know what is CD. So which theorem are we going to apply here? Right, we are going to apply the Pythagoras theorem. So what is Pythagoras theorem? The square of the hypotenuse is equal to the sum of the squares of the other two sides. This is pretty easy to remember. So our hypotenuse is AC square, the side opposite to the 90 degrees is our hypotenuse. So AC square equals CD square plus AD square. So here is the theorem written. Here is the Pythagoras theorem written. And now let's substitute the value. AC is 26. So it is 26 square equals CD is 10. 10 square we don't know. AD that is to be found out. So we have written it here. Now what is 26 square? 26 square is 676 and this 10 square I'm bringing it to the other side. So whenever a plus goes to the other side of the equation, it becomes a minus. So it is minus 100 equals AD square. So clear till this. Now 676 minus 100 is 576. 576 equals AD square. So now we know what is AD square. So what is AD? AD is equal to square root of 576. So what is square root of 576? Right, AD is equal to 24. Now we have got the value of AD. So let's write it here, 24. So now since we have got the value of AD, what else is remaining now? We have to find for AB. So once we find it out for AB, we have all the sides given there, right? So now let's take the triangle ADB. So in triangle ADB, so again we are going to apply the Pythagoras theorem because it's a right angle triangle. So which is our hypotenuse? Right, AB is our hypotenuse. So AB square is equal to AD square plus DB square. And you know all the values. We don't know what is AB. So let's leave AB as such. And we know what is AD. AD is 24 square plus what is DB? 32 square. So we have a bigger numbers here. Right? So you know what is 24 square because we have already found out the square root. Square root of 576 was 24 square root and the square numbers are vice versa. So 24 square is also 576. Plus what is 32 square? It is 1024. So now let's add up these two. 576 plus 1024, we get it as 1600. So AB square is equal to 1600. So what is AB? AB is square root of 1600. So now it's a pretty big number, right? So you need not find the square root using the long division method. It is pretty simple. Since there are two zeros, instead of two zeros, you will take out one zero outside. And 16 is also a square number. So root of 16 is 4. Pretty easy. So AB is 40. So we have got the value of AB. So now let's write here 40. So we have got all the values of the triangle. Now we have to find what is cot x, what is 1 by sine square y, 1 by tan square y, and 6 cos x minus 5 cos y plus 8 tan y. So let's find out that. Let me remove this so that we can start doing our questions. So now we know the values of the sides. So now let's start doing the question. So the first question is cot x. So cot x, what is cot x? What is the formula for cot x? Right, it is base by perpendicular. We have already learned this in our previous video. You can refer that. The link is given below in the description, or you can just simply click on the I button given above. So base by perpendicular. Here the reference angle is x. So as you could see, the reference angle x is here. This is our reference angle. So which is our base? Right, the side corresponding which is nearby to this reference angle is our base. So here our base is AD, and which is our perpendicular? The opposite side. The opposite side is our perpendicular, which is CD. So here the base is AD and the perpendicular side is CD. So what is the value of AD? What is the length of AD? Which is 24 by, and what is CD? 10. So the value of cot x we have found it as 24 by 10. You can either leave this as such or you can simplify this to 2.4. Both the answers are right. Now let's see the second question, that is the question B. What is asked? 1 by sine square minus 1 by tan square y. So first for that let's find out what is sine y. So sine y we are going to find out. Earlier it was the reference angle x. Now it is the reference angle y. So where is the angle y? Angle y is given here. So this is our reference angle. So what is the formula for sin y? Sin y is perpendicular by hypotenuse. So here what is the perpendicular? So the reference angle y, here our perpendicular side is AD. AD is perpendicular and our hypotenuse is AB. So you have to always see the reference angle. So our perpendicular is AD. AD by what is our hypotenuse? AB. So what is the value of AD? AD is 24. 24 by 40. So you can stop with this, or since you can still more reduce this into the lowest form, you can reduce this in the lowest form. You can divide the numerator and the denominator by 8. So you get it as 3 by 5. Isn't it easy? Now we have got the value of sin y. Now let's find the value of tan y. So tan y, we need to find what is tan y. What is the formula for tan y? Tan is perpendicular by base. The same thing, we are going to take reference angle y. Here our perpendicular is AD and our base is DB. So AD by DB. So what is AD? AD is 24 and our DB is 32. So 24 by 32, we can again make it into the simple form. So 24 and 32 are divisible in which table? Again, it is divisible by 8 table. So 24 divided by 8, which is 3, and 32 divided by 8, which is 4. So now we know the value of tan y is 3 by 4. So now what is the question given? 1 by sin square y and minus 1 by tan square y. So let's find that out. So the question is 1 by sin square y minus 1 by tan square y. Right? So what is sin? So what is the value of sin square y? Sin square y is 3 by 5. So it is 1 by 3 by 5 the whole square. We can square this. Minus 1 by tan square is 3 by 4. Tan is 3 by 4. So I will write it as 3 by 4 the whole square. Now let's square the denominator. So we would get it as 1 by 9 by 25 minus 1 by 9 by 16. So whenever we have the fraction in the denominator, we will reciprocate it. So when you reciprocate it, we get it as 25 by 9 minus 16 by 9. And now these are like fractions. We have the same denominator. So whenever we have the same denominator, we can directly subtract it. Whenever we have different denominators, those are unlike fractions, then we take LCM. So here no need to take LCM. So 25 minus 16, which is 9 again. So 9 by 9. So the answer is 1. So the answer for 1 by sin square y minus tan square y is 1. Now let's find out for the C question, which is 6 by cos x minus 5 by cos y plus 8 tan y. Now we need to find out the value of cos x. So let's find the value of cos x. So cos x is equal to, so what is the formula for cos? Base by hypotenuse, right? So here the reference angle is x. So the reference angle is x. The base is AD and our hypotenuse is AC. So what we will write here? AD by AC. So what is the value of AD? AD equals 24 and AC equals 26. So now we have found the value of cos x, which is 24 by 26. So this can be further reduced. We can divide these two by 2 table. So this can be further reduced to 12 by 13. Isn't it easy? So the next value we need to find is cos y. So what is cos y? Cos y equals the same thing, base by hypotenuse. So here the base is, here with reference angle to y, you can't write the same thing. Here the reference angle is y. When you see, take the reference angle y, the base is BD. So it is BD by, and the hypotenuse is AB here. So BD by AB. So what is the value of BD? 32. 32 by 40. So 32 by 40 can be further reduced to 4 by 5. We are dividing it with 8 table. 32 divided by 8 is 4. 40 divided by 8 is 5. Easy. Now let's find the value of tan y. So tan y. What is tan y? You would know, right? Just now we did it. It is perpendicular by base. So since it is with reference angle Y, which is our perpendicular? AD, and our base is DB. So AD by DB. So same thing we will get. So what is our AD? 24 by 32. So 24 by 32 can be further reduced. Both are divisible in 8 table, right? So this will be 3 by 4. Now we have got the value of tan. Tan y is 3 by 4. So now we have to find the value of all this thing. So I'm not going to write the question since we have very less space. So it is 6 by cos x. What is our cos x? 12 by 13. I will directly write the answers. Minus 5 by cos y. What is our cos y? 4 by 5. So cos y is 4 by 5. Plus 8 tan y is 3 by 4. So here is our values. We have just substituted the values here. Now let's find this out. How will you do it? Whenever we have a fractions in the denominator, we will reciprocate it. So 6 times 13 by 12. This we are using the KCF rule. Since there is a division, we will flip it around. Minus 5 times 5 by 4. Plus, this is as such, I will write 8 times 3 by 4. Now, let's cross out the same things. So here 6 and 2 would be crossed, 12 would be crossed out. 6 times 1 is 6. 6 times 2 is 12. Here there is nothing to cross out. There is no common things. And here 4 and 8. 4 times 1 is 4. 4 times 2 is 8. So here all the crossing out is done. Now let's find out 13 by 2 minus 5 times 5 is 25. 25 by 4 plus 3 times 2 is 6. And there is no denominator. So I'm just putting it as 1. So now as you could see, there are different denominators here. So whenever we have different denominators, these fractions are called as unlike fractions. So whenever we have unlike fractions, we have to take an LCM. So here 2, 4 and 1. So the LCM would be 4. So here the LCM is 4. So whenever we have LCM 4, we will multiply this by 2 and this also by 2 to make it 4. So 13 times 2 is, right, 26. And 4 we need not multiply anything. It's already 4. So this minus 25 will remain as such. And since here it is 1, I will multiply by 4. Here also I'll multiply by 4. 6 times 4 is 24. So there is a plus sign here. So I'll put plus. Be careful with your signs. You have to put with the signs. Now 26 minus 25 plus 24. So this is our answer we have got. Now how will we solve it? 26 minus 25, what do we get? 1. Right? It is plus 1. And then plus 1 plus 24, it will become 25. So our answer is 25 by 4. You can either leave this as such or convert this into mixed fraction. I hope you remember how to convert improper fraction to mixed fraction. If you have any doubt in this, you can refer my video. I'll put the link in the description, or you can just simply click on the I button above. So 25 by 4, we have to divide. 4 times 6 is 24. The remainder is 1 by 4. You have to use the QRD method. Please check on that video. You will have a detailed explanation of how to convert an improper fraction to a mixed fraction. So our final answer is 6 1 by 4. Isn't it easy? This question looks pretty hard. It's a pretty lengthy question, but it is very easy once you find out all the values of the sides. If you have any queries regarding these type of a question, comment down in the comment section. I hope this method was easy for you to understand. If you found this video interesting, click on the subscribe button and click on the bell icon so that you get a regular updates of all my videos. And if you liked the video, do not forget to click on the like button. So let's see the first question for today. From the adjoining figure, find tan x, sin y and cos y. So this is our figure given. This is a right angle triangle. As you could see, ABC is a right angle triangle. This is right angled at B. And there is another small right angle triangle which is SRB, and there is its right angled at R. And we have an angle X here, and there is an angle Y here. And we have few measurements given, which is SR equals 5, RB equals 6, and AB equals 18. So these are the measures given to us. With the help of these measures, we have to find the value of tan x, sin y and cos y. So let's take the first question, which is tan x. So to find this question, let's take the triangle, the smaller triangle, because it's x. So our angle x is here. So let's take this triangle, that is SRB, which is right angled at R. So let us take the triangle SRB. So I'm going to take these three triangles. And what is the value of tan in this triangle when we take? We know what is RS. RS is 5 and RB is 6. So we know how to write tan. Tan x equals, right, which is perpendicular by base. So when we take this perpendicular, which is the perpendicular for this triangle with respect to x, the perpendicular here is the opposite side. Always the side opposite to the angle is the perpendicular. I've explained in detail this part in my previous video. Refer to that so that you will have a detailed explanation about this. So RB is the perpendicular side and the base is the angle which side which is next to it, which is RS. So here perpendicular is nothing but RB and base is nothing but RS. So the value of tan x equals 6 by 5. Isn't it easy? Now let's find the second question for the second question, which is sin y. So our second question is sin y. Here the angle we need to find is y. So for the second equation, we will need this triangle which is A, R and S. So when we take this triangle A, R and S, we know what is AR. Since AB is 18, RB is 6, so this would obviously become 12. So we know the value of AR is 12. Now we know the value of RS is also 5. Now whenever we have to find sin y, what is the formula to find sin y? I hope you all remember that. Yes, it is perpendicular by hypotenuse. So here our perpendicular is, as you know, which is the perpendicular side? Right, the side opposite to the angle is our perpendicular side, which is RS. Here RS is our perpendicular because it's respect to y. Don't confuse this. This is with respect to x. RS was our base and with respect to y, RS is our perpendicular. So perpendicular by hypotenuse. What is our hypotenuse? AS. But in this case, we know what is AR and we know what is RS, but we don't know what is AS. So now let's find the hypotenuse, the side hypotenuse. So which formula would you be applying for this? Any guesses? Right, we are going to apply the Pythagoras theorem. So in triangle ARS, as you could see, it's a right angle at R, so which is the hypotenuse side? AS. So we can write the formula as AS square equals AR square plus RS square. And as we know, what is our AR? AR is 12 square plus 5 square. So what is 12 square? Right, 12 square is 144, 5 square is 25. So we get it as 169. So AS square is equal to 169. So what is AS? AS equal to the square of 169, which is 13. Isn't it easy? We have found the value of AS using the Pythagoras theorem. So this, the value of this is 13. Let's find the value of sin y. So for sin y, we know the perpendicular and we know the hypotenuse. So sin y equals perpendicular by hypotenuse. So what is our perpendicular? RS. RS is 5. And what is the hypotenuse? Which is 13. So we have got the value of sin y. Our second question is solved. Now let's find the third question, which is cos y. And this is also with respect to y. As you could see, with respect to y, we have found out all the three sides. Right? So what is the formula for cos? I hope you all remember this also. Right. So this is base by hypotenuse. So base by hypotenuse with respect to y, which is our base, AR is our base. So AR by
which is our hypotenuse? AS, as I've already explained. So now what is AR? AR is 12 and hypotenuse, which is 13. Hence we have got the value of cos y as 12 by 13. Isn't it easy? We just need to take the triangles, see whether all the sides are there, and if some sides are missing, use Pythagoras theorem and find the other side and substitute the value. Isn't it easy? So I hope this method is easy for you to understand. If you found this video interesting, click on the subscribe button and hit the bell icon so that you get a regular updates of all my videos. And do not forget to click on the like button. And today we are going to do an important topic, trigonometry. I have already explained the basics of trigonometry and how to apply it, how to apply the Pythagoras theorem, everything in my previous video. You can refer that. The link is given in the description below, or you can simply click on the I button given above. So let's start the question. What is given to us? Given 5 cos A minus 12 sin A equals 0. So what is given to us? 5 cos A minus 12 sin A equals 0. Evaluate. Evaluate means find. Sin A plus cos A by 2 cos A minus sin A. Now, as you could see, what is given and what is asked, it is totally different except the sin and the cos. But here it is 5 cos A, but we don't have anywhere 5 cos A. And here it is 12 sin A, and we don't have anywhere the sin A. So what are we going to do here? So let's take what is given to us. So what is given to us? We have 5 cos A minus 12 sin A equals 0. So this is what is given to us, right? Now I'm going to take this 12 sin A to the other side. So when I take it to the other side, I get here it as 5 cos A equals the minus sign. When it goes to the other side, it will become plus. So it will become 12 sin A. Now what can be done? Now what I'm going to do is I'm just going to cross multiply. I'm going to bring the 12 to the other side and cos to the other side. So here I will get it as 5 over 12 equals sin A by cos A. Now, as you all know, what is sin A by cos A? Yes, sin A by cos A can be written as tan A, right? So the value of tan A is 5 by 12. Now we have got the value of tan A. Now I know you all will be wondering, we have sin A and cos A here, but why are we finding tan A? Let me explain you. So I have written the question what has been asked here, sin A plus cos A by 2 cos A minus sin A. Now what are we going to do? We need tan A, right? So we are going to divide the numerator and the denominator by cos. So this will become sin A by cos A plus cos A by cos A. This will also, we'll write it as cos A by cos A by 2 cos A is there, no? So we'll write 2 cos A by cos A. Even the denominator you have to divide it with cos A minus sin A by cos A. Till this I hope it is clear. Now what can we do? Sin A by cos A will become as tan A. Right? And then cos by cos will become 1. So I will just directly write this as 1. Now 2 cos A by cos A. Cos A by cos A is again 1. So I will write it as 2 times 1 minus sin A by cos A will become as tan A. Right? So sin A by cos A is always tan A. Now as we know, the value of tan A is 5 by 12. So let me apply the value. This is 5 by 12 plus 1 by 2 times 1 is 2. I will put it as such, minus 5 by 12. Right? Easy. Now let's take the LCM for the numerator, because 5 by 12 is in fraction and 1 is a whole number. You can't directly add them. So let's take the LCM. So the LCM will be 12. I think you all know this. This will become 12 by 12 divided by, this will become 24. 24 minus 5 by 12. So since both the denominators are 12, I can cross out this 12. Now 5 plus 12 will become 17 over 24 by minus 5 will become 19. So our final answer is 17 by 19. Isn't it very easy? The question looked very tricky, but then we brought the question into tan A, and then from this question also we took it out tan, and then we found out the final answer. The final answer is 17 by 19. I hope you liked the video. If you have any queries regarding this type of a question, please comment down in the comment section. I'll try to solve all your queries. And if you found this video interesting, click on the subscribe button and click on the bell icon so that you get a regular updates of all my videos. And if you liked the video, do not forget to hit the like button. Thank you.